Hello. Energy storage in the form of heat is using a heat pump for heating a thermal reservoir and a heat engine to get back the energy. It's a bit tricky to see at a glance from Carnot efficiency equations that using a heat engine in reverse, meaning as a heat pump to heat up a thermal reservoir and then using that heat later to get back the energy, should have a round trip efficiency of 100%. Should have, because of energy lost with friction and other losses. And this is true for any temperature. If the temperature difference is high, engine efficiency is high and the heat pump efficiency is low. And if the temperature difference is low, the heat engine efficiency is low and the heat pump efficiency is high. As an example, let's say I have an insulated cold reservoir with water and a bit of ice, meaning at 0 degrees Celsius, and an insulated hot reservoir of wax with a bit of wax melted, meaning at 68 degrees Celsius. Connecting between these two reservoirs is a reversible heat engine. Maximum theoretical efficiency between those two temperatures is 20% for extracting mechanical energy and 500% for heat pump. I'll be using for simplicity kilowatts hour as units of energy. For charging, I use 2 kilowatts hours of mechanical energy. The hot reservoir will gain 10 kilowatts hour in form of heat and melt 164 kilograms of wax. The rest of 8 kilowatts hours of heat will be taken from the cold reservoir, freezing 87 kilograms of water, meaning those 2 kilowatts of hour of mechanical energy or work is converted to 10 kilowatts of hour of heat in the hot reservoir, a 500% efficiency as a heat pump. To get back the mechanical energy, the heat engine will recover the 2 kilowatts hour from the 10 kilowatts hour of heat energy flowing to the cold reservoir, a 20% heat engine efficiency. This is energy storage in a short explanation. Also, the cold reservoir is not needed because air from the environment is used for cooling and heating, but I have included for ease of explanation. And the temperature difference used usually is much higher. Now, the deal with free bricks is that you need stuff to heat up to store energy, and that stuff can be infrared bricks to become bricks. That will make brick firing a byproduct of energy storage, but not completely free because you still need to quarry, shape and dry the clay before firing. That also means that the increasing the work temperature to 1000 to 1200 degrees Celsius. This way of making bricks is completely carbon neutral and significantly reduce cost of production. This method won't work on making cement because thermal decomposition of calcium carbonate in calcium oxide and carbon dioxide is an endothermic reaction in that takes energy and releasing carbon dioxide.